Let's take a look at Unit 3, Topics 7 and 8. The basics. So just as a reminder, an organism wins the game when it reproduces and its offspring reproduce. Most large organisms, that means humans too, follow that logistic growth model because we're bound by limiting factors. Limiting factors dictate the carrying capacity of an ecosystem, which is represented by that letter K. Populations that overshoot their carrying capacity can suffer a die-off. Humans have figured out how to bend the rules of the game, but we can't break them. So some important concepts. Crude birth rate and death rate. Birth rate or death rate is the number of live births or deaths per 1,000 people in a population over the course of a particular year. So number of births or deaths divided by the total population times 1,000. So it's always out of 1,000. Doubling time is an equation sometimes called the rule of 70. The time it takes a population to double at a specific rate. It only works when a population is growing exponentially. So you take the rate at which it's growing, and you take that 70%, and you divide it by that rate, and that tells you the number of years that it will take for that population to double. Factors driving human population growth. Whether population grows, shrinks, or remains stable depends on birth rate, death rate, and migration. Births and immigration add individuals to the population. They're coming in. Deaths and emigration remove individuals from a population. So here's the equation when we're looking at that. Births plus immigration, and we add the deaths and the emigration, and we subtract births minus deaths, or all the ones that are being added minus the ones that are being subtracted, divided by the total population. Times 100 gives us our percent population change. Fertility rates. Fertility rates come in two forms. We have total fertility rate. This is the average number of children born per woman of childbearing age. This number can change based on numerous factors. And then we have replacement fertility rate, the number of children a couple must produce to replace themselves. Mathematically, 2.1 children per woman of childbearing age. Practically speaking, it's actually 2, but we have that 0.1 because we need a little bit extra because not every child will survive into adulthood. So 2.1 is considered that replacement fertility. Populations that are at replacement fertility are considered stable, not growing or shrinking. What factors influence total fertility rate? Well, there's several things. The age at which females have their first child. The younger the age, the more children she can produce over her lifetime. The educational and the employment opportunities for women. One of the most significant factors is this education of women. Providing these creates new opportunities for women, often have children later in life. Women are becoming educated or employed, they often put off childbirth. Access to family planning includes access to contraceptives, education, and healthcare. And then governmental policies. They help support all of these other things that we just mentioned. So all of these factors have the potential to positively or negatively impact population growth. So a government could do things that would promote family planning or do things to outlaw it. Some more, continued. The importance of children in the workforce. So this is especially true in rural or poor communities. More children equals more earning power for the family. The cost of raising and educating children, the more expensive these become, the fewer children couples have. Pension system. If there's a pension system that's available, parents don't need their children to support them after they stop working. So this is some of the things that we talked about where the oldest son takes in the parents to care for them. So other things like nursing homes fit into that. And then urbanization. Things become more expensive in cities, housing, food, etc. So women are a key factor in all of this. They're a critical concept in demography. Empowering women reduces population growth rates. Fertility rates drop when women are given access to things like contraceptives, family planning, better educational opportunities, and better employment opportunities. The signs of a healthy population. When analyzing human population, it becomes necessary to assess the health of that population. A population's health can provide clues to how a population might change in the future. Health is measured with two metrics, life expectancy and infant mortality. So for life expectancy, it's the average number of years a person born in a particular year can be expected to live. In 1955, the global life expectancy was 48 years, and in 2017, it increased to 72 years. Factors that influence life expectancy: access to quality medical care, access to good sources of nutrition and clean water, laws and regulation protecting workers, education opportunities, and then access to quality sanitation. Infant mortality is considered the best metric to assess a population's quality of life. The number of babies born per 1,000 people who die before their first birthday. Factors that influence infant mortality: access to quality health care, nutrition. There's two ways we look at that. Undernutrition is insufficient food, not having enough. Malnutrition is you have enough food, but not the right quality of food or not the right ingredients. You, for example, only eat rice as your entire diet, so you're malnourished. Important in general, lower infant mortality rates means lower total fertility rates. If we have less babies dying, we're going to have to birth less babies. In areas where the infant mortality rate when the infant mortality rate is high, families tend to have larger families in the hopes that some of their children survive to adulthood. The Mathusian theory is human populations can be influenced by both density dependent things like disease, food, availability, space, and independent factors, things that doesn't matter how dense the population is, like drought, storms, fire, etc. Mathusian theory in three parts. Human population will grow exponentially. Resources will grow arithmetically. So resources are this straight line. Population is growing exponentially. But here we're going to have this point of crisis where the population is exceeding the resources. This means that the resource availability has to be the check on population growth. And so there's where we have an abundance of resources, and then we're going to go to where we don't have an abundance. If population grows beyond the resource production, famine, disease, and war will bring the population back in check. And that's where we have that scarcity. So, to recap, human population is driven by births, deaths, and migration. Total fertility rate represents the average number of children born per woman of childbearing age. Replacement fertility rate is about 2 children per woman, and we use the statistic 2.1. Empowering women is the key to controlling human population growth. Life expectancy and infant mortality are 2 metrics we use to measure a population's health. According to Malthus, resource production serves as a check on exponential human growth.